Next up, we have Michael Penn with us. Michael Penn is a William R. Keenan Jr. Professor of Religion at Mount Holyoke College, and he's here to talk about another Five College Digital Humanities project he's been working on, which is a modern technology against ancient manuscripts project.
Okay, so 180 seconds of something completely different. So the historical study of almost all pre-modern cultures depends on the analysis of manuscripts. And the analysis of handwriting, a practice known as paleography, is the most common way to establish when a manuscript was written, who wrote it, and where it was produced. A computer will never replace a human expert, but nonetheless, at its base, much of paleography is shape comparison, a task that computers have become increasingly good at. So our team of 2 professors and a dozen students has asked, how can recent advances in the digital analysis of handwriting help us better establish the provenance of ancient manuscripts? We aim for the following product. You upload a few manuscript pages and identify some letters. The computer compares the letters in your test document with those in its database, and it then lists those documents whose handwriting is closest to yours. It also compares your manuscript to those securely dated to help you establish a likely composition date for your document. Now, our system has 2 components. The first component is a database of manuscripts written in the Aramaic dialect of Syriac, which is the lingua franca of the Middle East from about 200 CE to 800 CE. To assemble this database, one uses a Java interface designed and coded by Smith students. A student enters in the metadata and uploads about 10 images of a given manuscript. She then uses a selection box to identify a given letter. After an hour or so, she will have identified about a dozen of each of these letters and then moves on to the next manuscript. Now, currently our database has a little over 100 manuscripts in it that are fully encoded, and we anticipate a little over 250 by late spring. The second component analyzes this data in MATLAB. Currently, our most successful algorithm we call letter congealing. The computer takes every example in its database of a given letter, let's say 3,000 examples of the letter Olaf, and it produces a weighted mean, what I think of as a humanist as the Platonic ideal of an Olaf, against which all other Olafs can be measured in terms of direction and distance. The system then compares every example of the letter to this Platonic ideal in 3 different ways. Now, to assess our system, a Smith engineering student assembled a database of 20 manuscripts. Every time the computer successfully identified the manuscript a previously unseen page had come from. Now, 100% success rate for a data set of 20 documents doesn't guarantee such a success rate when we have a database of hundreds, but it was a really encouraging result for a prototype. Now, last year, our students made a new interface. They created what we're calling a harness, which allows data to flow from the interface directly into MATLAB. They photographed manuscripts at the Harvard and the Cambridge University Library collections, and they spent a month in London at the British Library directly handling and analyzing the largest collection of Syriac manuscripts. This year, they're continuing to expand the database and further test and refine the system's accuracy. Their participation reflects our belief that one of the best ways for students to learn about the digital humanities is through their direct involvement in all aspects of the design, implementation, analysis, and use of a cutting-edge digital humanities tool. Thanks.